Hello everyone. Today let's solve the problem number 704 binary search. Right. So what the question states here, we are given a sorted array nums. You can clearly see here we have been given a sorted array nums. Right. So what we need to do then, we have to find the index of the given target using the binary search. So here target has been given 9 and here the 9 is at the particular index, basically fourth index, right? So we need to return that index using the binary search. They have strictly mentioned the question name itself is the binary search, right? So again, let me read out the question loud. So here, given a sorted array nums, we can one thing before discussing the question, we can perform the binary search only on the sorted arrays, right? So here we have been given the sorted array nums, given the index of the given tag. I mean, find the index of a given target using the binary search. If the target is found, then we have to return its index, otherwise we have to return -1. So just keep this in mind. If the target is found, then we have to return its index, otherwise we have to return -1. So the algorithm must run in big of logarithmic n time complexity, and again they have mentioned here clearly the algorithm must run in big of logarithmic n time complexity. Each element in the array is unique and sorted in the ascending order. So basically, whenever it's big of logarithmic n, we have to write the algorithm in this one logarithmic n. Then we will think of the binary search itself, right? First, so the algorithm must run in big of this one log n time complexity, and each element in the array is unique and sorted in the ascending order. They have strictly mentioned this one, right? So this is the question. I hope the question is completely easy, right? Completely easy to understand. Basically, here 9 target has been given 9, and we have to find the target, and the target of the 9 within the nums array is 4. So that's what they have written here, right? So that's what they have written here. Let's come to the second example here. So just give me a second, 1 second. Yeah, let's come to the second example here. So here we have target 2, and 2 is present at the 2 is not present in the array at all. 2 is not present in the array at all. In that case, if the 2 is not present in the array, then we have to return -1, right? Here see, in the explanation they have given same. This is one of the edge cases basically. 2 does not exist in the nums, so we have to return -1. 2 does not exist in the nums, so we have to return -1. So this is fine. So I hope the question part is completely clear. Let's quickly discuss the approach followed by the complexities, and then let's write the code, right? So here let's come to the approach part. We have considered the same example, first example, so that it will be easier for us to understand, right? So here, first step, what we will do, we will initialize the pointers. As we are going with the binary search, we will be initializing the two pointers. One is left and another one is right. Left to the 0th index, or the first this is 0 based index, right? So 0 based index means this one, 0th index. Left is initialized to the 0th index, and the right is indexed to the right is initialized to the last index, nothing but length of the nums -1, right? Length of the nums -1, nothing but here in this case it will be this one. Yeah, here it will be basically this one. We are what initializing to the index, basically this will be 0. Don't get confused, we are not this one, what we are not initializing to the this one element that is present in the particular index. We are initializing to the index itself. Here this will be 0, and this is the fifth index. Here you can count 0 1 2 3 4 5, right? So here right will be quite obviously 5 in this case, right? So we have to calculate the middle. Pure binary search, right? Mid equals nothing but this will be 0 initial index plus 5 by 2, 5 by 2. So this will be basically 2.5. So absolute number, we will get output 2 itself, right? 2. So value is here, in this case value is 3. Value of the second index is 3 here. This one I'm speaking of. Value of the second index, we have got the index 2. Basically value is 3 now. 3 is less than 9. 3 is less than 9. So what we will do, we will search in the right half. We will search in the right half. Now what we will do, as we have to search in the right half, pure binary search here. So we will go with the left equals mid plus 1. We'll go with the left equals mid plus 1. Here in this case it would be 3. it would be 3, right? So we will move basically left pointer, right? We'll move basically left pointer, left equals mid plus 1, nothing but the value will be 3. Now again we'll calculate the mid. This time it would be 3 plus 5, this one next element. So this will be 3 plus 5 by 2. 3 plus 5 by 2 is nothing but 8 by 2. 8 by 2 is nothing but 4, right? 8 by 2 is nothing but 4, right? So value is 9. Value is 9 here. In this case 3 plus 5 by 2 is nothing but 4. Value is 9 here. This value I'm speaking of, value is 9. So target is found at the fourth index. 4 we got, right? Value is 9. Basically we'll check for the element at the fourth index. See here, this is fourth index, right? Value is 9 and 9 is equivalent to the target here. You can clearly see here 9 is equivalent to the target. So we have found the this one value at the target, I mean value at the index 4. Index 4. We have found the target value at the index 4 in the nums array. So we will return 4 as the answer. We will return 4 as the answer. Simple, right? We are performing pure binary search here, right? So 4, the answer that we got is 4 here, which is equivalent to the output that they have given for the example one. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case. So before writing the code, let's do one thing. I hope the approach part is completely clear. Before writing the code, let's discuss the complexities very quickly. Complexities very quickly. So what will be the time complexity here? So we all know that the time complexity of the binary search would be big of logarithmic n, right? So the time complexity would be for this particular problem will be big of logarithmic n itself, because each step halves the search space in the binary search, right? Each step halves the search space in the binary search. So quite obviously the time complexity would be because of logarithmic n. And what would be the space complexity? Space complexity would be big of 1. Why the space complexity would be big of 1? So we are not making use of any extra space. All the operations in place, right? So we are performing all the operations in place. So space complexity would be big of n as well. So the time complexity would be big of logarithmic n, and the space complexity would be big of 1 for the code that we'll be writing in the future, right? I hope this part is completely clear, right? I hope the approach and the complexities part is completely clear. As we are familiar with the approach and complexities part, we are good to write the code. Let's start writing the code. Initially, let's go with the 2 pointers, left and right. Let's initialize the left to the 0 or 0th index here, and let me initialize the right to the last index, nothing but here nums dot length minus 1. So this is fine. So next step is binary search, pure binary search, while left less than or equal to right, means we have to continue while loop or while search space until it is valid, right? So here we have to, within the while loop, the first step is we have to avoid the potential overflow. We have to calculate the mid, nothing but here end mid equals left plus right minus left by 2. This is fine. So next step is let's write the simple if condition. If nums of mid, so let's articulate the same thing in the form of code, whatever we discussed in the approach, right? If the nums of mid equals target directly, then what we will do, we have to return the target, I mean we have to return the mid. So we have to return the mid in that case, right? So here in this case return mid. This is fine. Else if this one nums of mid, uh, if it is less than target, then what we will do, so here left equals mid plus 1, right? So left equals mid plus 1. So this is fine. The final part is else, uh, then what we will do, we'll go with right equals mid minus 1. Right equals mid minus 1. This is fine. This is fine. Right equals mid minus 1. Nothing but here, if it is present in the right half, then we are going with the left equals mid plus 1. So accordingly with the condition nums of mid less than target. So here if the target is in the left half, then we are going with the right equals mid minus 1, pure binary search. The final step here is if the target is not found, we have to return minus 1 accordingly with this edge case we are going with, right? So this example, they have given the examples wonderfully for the sake of understanding. Let's return minus 1 quickly. So this is it for the code. So let me format the code once and let me hit the run button. So this has to work. Let's see. I have misspelled right line number 13. Just give me a second here. Yeah, let me run this one again. So you can clearly see here, right? You can clearly see here the sample test cases are getting passed. The sample test cases are getting passed, right? So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed, right? All the test cases are getting passed means the code works absolutely correct on this case, right? So the code works absolutely correct on this case. I hope the solution part is completely clear. I hope the solution part is completely clear along with the approach and its complexities, right? For now, this is it. Thanks for watching, guys.